Hey, I'm Fight the Flat Earth. Welcome back to the channel that cuts the brake lines on stupidity's car. Today is episode 8 of Explaining Simple Stuff to Flurfs, and we're going to tackle the big one, gravity. Now, I will be the first to admit that gravity is anything but simple. But there is simple things about gravity that Flurfs just keep misunderstanding, misrepresenting, or outright denying. So with a little help from Bob the Science Guy, I'm going to put these morons in their place. Because frankly, I'm sick of defending gravity. It's a real thing. And if you're going to keep denying that, how about you just ignore gravity completely and float the fuck away forever and live on your magic space pizza away from the rest of civilization, because we will be fine without you. I also love the intro you're about to see because it triggers the Flurfs so much. I can just imagine their blood pressure rising every time they hear,
"We're living on a disk, floating through space, with a tiny sun."
Now that the Flurfs are sufficiently triggered, let's do a little bit of science. I'm going to start with one of the classics. A lot of Flurfs claim that gravity is just buoyancy and density. Here is an idiot Flurf to explain why they think this stupid shit.
Hello, flat earth researchers, debaters and debunkers.
That's right, it's everyone's least favourite creepy uncle fuckwit word.
To understand the illusionary nature of gravity, we can look at this space and ask, is there gravity going on in the air here?
Yes, of course there is gravity going on in that space, in the same way that if there is a forest fire and there's no one there to see it, the trees are still going to get burnt. Why do you think the air is being held there?
Is there a downward force created by the mass of the Earth within this space? No.
Yes, there is. The mass of the Earth is creating a downward force of 9.8 meters per second squared.
Not within any medium is there a downward force by itself. Not until we introduce something like this ball.
That's right folks, you heard it here first. We can manipulate gravity. We just have to put a small ball in front of a camera, filming in portrait mode for some reason.
And then, because this ball is a mass with a volume and density that is more dense than the air, it will drop. Yeah?
And there we have it, the magic phrase. It will fall because the air is less dense than the ball. The logic is so broken, and I have explained it many times. The air underneath the ball is less dense than the ball. You're right, but so is the air above it. In fact, our atmosphere has a pressure gradient all the way from 14.7 psi at sea level to 0 in space. So the air above the ball is ever so slightly less dense than the air underneath it. So by your logic, fuckwit word, the ball should go up.
Air cannot support it, but the speed at which it will drop is simply what is called gravity.
The speed at which it will drop is called gravity. I mean, that's so wrong it physically hurts me. And here's the thing, it's not just a constant speed. As it falls, it accelerates. And we all know that acceleration requires a force.
Take it away, there's no gravity. There is only gravity when you have an object to drop through the air.
No, you train wreck of a human being, you don't have the ability to switch gravity on and off.
If this ball was filled with helium, of course it would float. Yeah? It doesn't defy gravity to float.
No, you are right, and no one said that it defies gravity. That is a stupid thing to say. One of the many. One of the simple things you constantly fail to grasp is that for a ball filled with helium to rise, there must be a downward force acting on it for the helium to create a buoyant force. This is reflected in the formula for buoyancy, which is B equals PFVG. That little g is very important in the buoyancy formula because do you know what that stands for? Gravity. So it's not defying gravity, it's part of the heliocentric model. And you saying things like that proves you have no idea about the model which you are arguing against.
If this was a vacuum and this ball was helium, then of course the helium would sink because you have a vacuum with 0 density. So even a helium balloon or ball would be heavier and more dense than the medium it is in. It has nothing whatsoever to do with the Earth beneath it.
No, you fucking idiot. It has everything to do with the Earth below it. That's why the hypothetical helium balloon would fall in a vacuum. You said it's heavier, so you mean it weighs more. Well, once again, you're talking about something that requires gravity because weight is a force, a function of gravity, as shown by the formula for weight, W equals mg, where W is weight, m is mass, and g is once again gravity.
It is purely an illusion of perception done with mathematics.
You know, fuckwit words, sometimes I envy your ability to use word-salad like that. In that clip, you said 9 words, managed to string them together in such a way to strip all meaning from any of them. Well done.
There are not two forces, gravity and a buoyant force, acting on things. There is only ever a direct relationship between what you put into the medium and whether that thing is denser or less dense to create up and down. Thank you very much.
But there's the problem. That up or down, where does that come from? All the things that you talk about require a downward accelerating force to work. Gravity can't be buoyancy and density because, as I explained, that would make things go up in our atmosphere. In the reality we actually live in, that doesn't happen. But what do you guys know about reality, huh? So gravity isn't whatever fuckwit word was on about. So what is it? Let's go to the remedial classroom to explain. Welcome, class. I think there's been a mistake with the curriculum for you guys because this seems well above your level. But then, so is tying your own shoelaces. No, Mr. Pratt, you can't tie your own shoelaces. You have Velcro. Well, I'm sure you are proud of yourself. Now, if you don't mind, look, class, just take notes as best you can. Let's look at gravity as a force. We know we can do that because it causes things to accelerate towards the Earth at 9.8 meters per second squared, and acceleration requires a force. Newton noticed this and, based on experiments and observation, gave us the universal law of gravitation, a mathematical expression of the phenomenon of mass attracting mass. G equals m1 times m2 over r squared. Newton's law of gravitational attraction states that every particle attracts every other particle with a force that is directly proportional to the product of the object's masses and inversely proportional to the distance between their centres. Take these two masses, mass 1 and mass 2. Assume mass 1 to be bigger than mass 2. Using the law of gravity, which I've shown you already, we can see that as the mass of the objects increases, so does the attractive force between them. So as mass 1 is bigger than mass 2 will accelerate towards mass 1. The bigger mass 1 is, the faster the acceleration. This formula works and allows us to do all kinds of predictions. Okay, class, did you understand any of that? Didn't think so. Thank God it's home time. Get the fuck out, you idiots. So we see that mass attracts mass, but Flurfs say we can't prove that, but that's because they refuse to accept the Cavendish experiment proves it. Here's Bob the science guy to explain why.
Lord Henry Cavendish was a rather interesting sort. Not only was he one of the richest men in England at the time, he had some rather unique personality characteristics. He was very painfully shy, and at one time he was going up the stairway in his house and actually encountered one of the maids. He was so taken aback by that and uncomfortable with it, he actually built a second stairway that only he would use so that it would never happen again. He was so uncomfortable talking to people that the only way that you could speak with him was to walk into the room that he was in and address the room, and he would then answer the room. He entertained so infrequently and was so eccentric, most of his neighbors thought he was a wizard. Well, the experiment in question was conducted in England in 1797 to 1798. It was designed to measure the weight of the world to allow Cavendish to determine the density of the Earth, which was a great question at the time. Now, spoiler alert, he was able to determine the density of the Earth, and interestingly, it was much closer to that of liquid iron than the rocks of the crust. The Cavendish experiment was the first experiment that I'm aware of that actually indicated that the Earth may have a molten iron core. His result for the weight of the Earth was within 1% of the currently accepted value. The way that we do experiments in science is following something called the scientific method. Now, the scientific method is just that, a method. While there's no particular way of doing it or requirement of a particular step, it does follow some very basic principles. And I'd kind of like to go over those before we show how Cavendish applied those principles to his experiment. Now, the first part of scientific method is to actually come up with some sort of a question that you want to answer. This could be, what is the density of the Earth in the case of the Cavendish experiment? It could be why birds fly or why the sun rises. The second step is to try and formulate some sort of an explanation for what you think is happening. This is called the hypothesis. Now, during the course of formulating your hypothesis, you also want to sit down and figure out the anti-hypothesis or the null result. So, for example, if you believe the Earth is curved, the null hypothesis would be, what would we see on a flat Earth? Now, sometimes this hypothesis builds on something that we already know. We take advantage of scientific study that came before us and try and expand it. Other times when we're going into new territory, we just simply make a scientific wild guess. But in any event, once we do have an hypothesis, we want to see if we can make a prediction with it. This is what we're going to actually test. While in some branches of science, observational studies are the rule, an example would be astronomy. In physics, we can many times do an experiment to try and test the validity of our hypothesis. Now, the final step, obviously, is to come to a conclusion. You review the results of your experiments, decide what they mean, and then you present those results to the scientific community for peer review. Now, let's see how Cavendish went through this. Now, the first step, of course, was to decide what he wanted to test, and that was he wanted to determine the density of the Earth. His hypothesis was that if he could measure the gravitational attraction between two masses of known weight, he could use that information to find the mass of an unknown weight, specifically the mass of the Earth, which would allow him to compute the Earth's density. So let's have a look at how he set up his experiment. So before we get started, let's go ahead and organize our thoughts. The first thing is, he used Newton's universal gravitational law that said the force of gravity is proportionate to the product of the masses divided by the radius squared. Now recall that this says the force of gravity is proportionate to. That's the equivalent of saying that my weight is going to be proportionate to the amount of food I eat. If you want to get exact numbers, you're going to need some sort of a converting constant in there. Now let's take a moment and just look over how he set up his apparatus. This is a modern version of it using a laser. He had a room that he built in his garden shed. The room had walls 2 feet thick to minimize any changes in temperatures and stop any breezes on this very sensitive setup. Now, what you have here is 2 large balls made of lead. The ones Cavendish used were about 300 pounds apiece. Now, between them, you have a rod with small weights balanced on the end. Now, there's a couple of things that are very important here. First of all, the center of those small balls and the center of the large balls have to be on the same level so that they're in the same plane, so to say. Now, the first thing that you do is you hang these up parallel to the ground or level with the ground. Now, the reason that you do that is the Earth itself has gravity. So what you want is you want gravity pulling down on this entire apparatus in one direction, but you want to test it in a different axis, 90 degrees to that direction. Now, the gravity of Earth is pulling down equally on all of these objects, so it's essentially canceled out. Now, the next thing that you want to do is you want to hang this bar from a torsion wire, and you want to allow it to reach equilibrium. So you have it in a position where it is 90 degrees, so equally affected by each of those large balls. And it reaches a point where it just sits there and doesn't move. It's in balance. So once it's in balance and not affected by the large weights, we want to go ahead and introduce our dependent variable, and that is the large weights. Now, the way that we're going to do that is without moving the small weights on the bar. We're going to rotate those large weights so that they come up relatively closely to the small weights. In Cavendish's experiment, they were about 8 or 9 inches apart. Now, what will happen there is the laser that originally was reflecting back on itself now will show that the small weights are twisting a little bit on that torsion wire. And as you can see, that forms an angle between the laser and the outgoing laser beam reflected off that mirror. Cavendish's example, he had telescopes built into the side of the rooms with vernier scales on them so that he could measure very fine differences in the angle once the large balls were brought into approximation with the smaller balls. Now let's put this in motion so that you can see it in action. Watch how the laser starts off shining onto a certain spot on a scale, and then as the large masses are brought close to the smaller masses, the attraction between the two of them causes the lasers to swing. Have a look. Now let's go ahead and see if we can figure out what this twist is showing us. So we're going to go ahead and we've got our torsion wire coming down to a rigid rod. And then it's got 2 small masses on each end. And again, the force of gravity is going straight down towards the bottom of the page, so it's affecting each side equally. Now, once we have this small weight and torsion wire set up, what we want to do is we want to set it at 90 degrees to the large masses that are on the outside, as we can see here. Now, by placing the large weights at 90 degrees, we're balancing this apparatus and letting the small torsion rod find its neutral position. This is its home position now. Now, once it's had its neutral position located, we swing the large, heavy masses up next to the small masses. We get a gravitational attraction between the small mass and the large mass. That attraction puts a twist in the wire, and the wire itself tries to spring back to neutral by resisting that twist. Eventually, after oscillations back and forth, it reaches a neutral position again. Once that occurs, we can actually measure the resultant angle. This is the balance point between the gravitational attraction and the twist in the wire. Now that we understand what we're looking for, let's watch it in action. Notice if we move the large masses away, the small masses return to their neutral position. Okay, now we head back to the kitchen table and we do a little bit of math. The first thing that we have to do is we have to determine what the torsion coefficient of the wire is. Then using the length of the wire, that torsion coefficient, etc., we can figure out how much force is needed to counteract the gravitational attraction between those balls. From that, we can determine the gravitational constant, and then by substituting a few terms in here, we can actually weigh the Earth. Now, I've done that in another video, but I don't want to go heavily into the math. The main thing that we wanted to do on this particular video, it was to show how the scientific method was used, how the experiment was set up, and what kind of results it gave.
Thanks, Bob, for proving that Anthony Riley is once again wrong about something. He's constantly saying that the Cavendish experiment is not an actual experiment. He was wrong. Surprise. Let's continue proving him wrong. He recently did a video directed towards me from when I previously mentioned gravity. So let's have a look at what he said and why he is an absolute moron.
There is no evidence for gravity.
Straight out the gate with pure, unadulterated stupid. Yes, there is evidence of gravity, but like all flirfs, you, Mr. Liley, are not willing to accept any evidence because you don't even understand what science is.
Things fall at 9.8 meters per second squared. They don't. Check this clip out. This guy here, clearly, is not falling at 9.8 meters per second squared, is he?
Well, no, technically he isn't, but you are misrepresenting what I said. Shocking, I know. The thing is that the person in that tank of water still has a downward accelerating force of 9.8 meters per second squared acting on him. But to calculate his speed, you would have to take into account the buoyant forces acting on him as well. But you're just happy to lie, aren't you, Liley?
I'm going to keep mentioning this until it becomes ingrained in bowlers' heads.
Here is where Liley starts to show his true colours and display his ego. He thinks he's teaching us. He wants this ingrained in our minds. I mean, that's not even teaching. That's attempting to indoctrinate us.
Gravity does not exist the way that you guys push it, especially the way this guy's pushing it.
I'm not pushing gravity. I'm explaining the basic concepts you seem to think you are smart enough to disprove. Gravity is a fact. It exists, and using the law of gravitational attraction, we can accurately predict pretty much everything in the universe. But go on, keep spouting bullshit. We all know you're just trying really hard to be dumbfuck of the year, and we don't want another second place, do we?
This is a citation, a current citation dated 2015 by George Musa on Scientific American. There is a copy of the link. Rather than copy and paste that, you can just literally type in that and you will find it in Google. It's very easy to find. And as we skim through this, I'm going to point out a couple of key paragraphs.
And there we have the limits of his research. He skimmed through the article and cherry-picked things that he thinks proves his point. I read the entire article, and the first thing to say to Liley is that this article should not be used as proof of anything. It's not a scientific paper. Just because it's on Scientific American doesn't really mean anything. It's not a peer-reviewed, tested and accepted proof of anything. It's an article. Somebody's opinion. But I will break down what the article actually says. It's about the author's personal experience in understanding some of the things that Einstein said. It covers how Einstein figured out that gravity is not an invisible force, but the curvature of space-time that can change the locality of something, and how it relates to and expands upon Newton's understanding of gravity. In short, it actually helps explain how Newtonian gravity is the what and Einsteinian gravity is the why. Yes, Newton didn't have a complete understanding of gravity, and Einstein figured out how gravity is mass warping space-time, and that was a big part of him figuring out how general relativity works. But that doesn't mean that Newton was wrong, because it was Newton's equations of orbital mechanics that helped us first put man on the moon.
Referencing Newton, initially his concept of gravity seems to imply the phenomenon of non-locality, because the attractive force between masses appears to act magically across expanses. Albert Einstein's general relativity instead ascribed gravity to the curvature of space-time. Right? The key word is instead, not as well as, not interchangeably, it's instead.
And that's what happens when you only skim through an article, you dumb fuck. It literally explains in the article how the two explanations of gravity are intrinsically linked.
Yet it introduced a deeper sense of non-locality by showing that space-time positions have no intrinsic meaning. That's a semantic. It's a moot point that we can come back to later on.
Oh, Liley, you're just showing your dishonesty there. That one sentence literally destroys your whole argument for using this article. So you describe it as a moot point. You know that thing I keep saying about you idiots writing my content for me?
Let's get this message into silly ballers that claim silly things.
See what he thinks of you guys.
Because it's not okay to misquote science in the belief that you're right when it's clearly and evidently wrong.
And I think we can just leave Mr. Liley to his little fantasy world where cherry picking and misquoting science and even just articles on a website makes you right. The whole article says that gravity is mass warping space-time, which within the understandings of Newtonian physics manifests as a force. On Earth, a downward accelerating force of 9.8 meters per second squared. Anyway, thanks for watching today. I hope you've enjoyed this video, and if you have, please leave a like, make sure you're subscribed, and you've got the notification bell on so you never miss anything from Fight the Flat Earth. As you're watching this, I'm hard at work on Jeranism's episode of Flirfs Are Idiots, and I will have that with you by the weekend, as well as a new comment show because the Flirfs just can't help themselves. On Saturday, I'll be hosting and moderating alongside Goddess Engineer for the first time on Non Sequitur Show's Flatterday Night Fights, as Schrodinger's cat debates Flat Earth Fokker at the earlier than normal time of 4 PM EST, 9 PM GMT, And then at 8 PM EST, 1 AM GMT, I'll be having my own discussion with the Flat Earth Brothers about the shape of our world. A massive thanks to all my Patrons. I'm also working on updating the Patreon page and my first Patreon-only video. I've also added the Patreon-only channel on my Discord server, and I'll put details of that on the Patreon page. But if anyone else wants to join my Discord server, I'll make sure the link is in the description, or you can contact the God admin, Marvel Girl. I'll see you soon, and remember, stupidity is not a right. Fight the flat Earth.
We're living on a disk, floating through space, with a tiny sun.